Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to provide an example here of how to calculate centroids. So what we're going to do is we're going to take this blue geometry here, where this bottom of it is defined by the curve y equals minus bx squared over a squared, and this distance is a and this distance is b. And what we're going to try to do is calculate the x and y coordinates of the centroid of this geometry. So the first thing you have to decide is whether or not you want to use horizontal or vertical rectangles. If we do a horizontal rectangle, let me talk about that setup. Let's see. This length, let's see, from here to here is a, from here to here is distance is minus x. The length of that rectangle would be a plus x, believe it or not. I know that might seem a little strange, but y plus x, but a is a distance, plus x, x is some negative number. That would give us this length right here. The width of that rectangle would be a dy. We could also set the rectangle up horizontally, and I think I'll go ahead and do that here. So I'm going to set myself up a horizontal rectangle. The width of this rectangle is dx. The length of that rectangle, let's see, length would be equal to minus y. Y is some negative number here. The length, this would make the length positive. The centroid of that rectangle is here at its geometric center. From here to here is the x coordinate of the centroid. From here to here is the y coordinate of the centroid of the rectangle. And these are the things that we're going to be working with here. So to find x bar, what we're going to want to do is we're going to be averaging this as we move left to right. So we're going to take x, and then we are going to multiply by the area of this guy. Now, x is some negative number here. I want to weight this by area. I want a positive value there. So to do that, let's take minus y. That's going to be bx squared over a squared, and multiply it by dx. And again, I drop the minus sign because I'm taking x, this is what we're averaging, and we're giving it a weight, and I just want that dA to be some positive value. Then what we're going to do is we're going to add these up, integrating from minus a to 0. You want to integrate in a forward sense, so we're integrating from minus a to 0. Then we have to divide out the total area here. Now, the length of this, again, is minus y, so that's going to be bx squared over a squared, and then times the width, dx. And we will, again, integrate from minus a to 0. All right, so it's really all about this. This is what we're trying to average, and we're giving it a weight, and we're weighting it by the area of the rectangle. So x times the area. And then in the end, you have to divide out the total area, and that's what this does. All right, so let's see what we get. B over a squared might as well come out in front. Antiderivative of x to the third is x to the fourth over 4. And that's evaluated minus a to 0. I'll take a look at that again in a minute. We'll do the bottom here. B over a squared can come out in front. Let's see, antiderivative of x squared is x to the third over 3 from minus a to 0. And we'll take a look at that in a minute. All right, so putting in 0, of course, you get a 0. And don't forget now fundamental theorem of calculus, or I guess it's second fundamental theorem of calculus. You're doing like this evaluated here minus this evaluated here. And when we put an a to the fourth here, let's see, we're going to have b over 4. And this will end up being an a to the fourth, 2 of them down here. We're going to get a squared with a minus sign. All right, in the bottom of this thing, let's see, b over a squared. When we put a in, or well, don't forget we're putting this limit in first. So 0 minus, now we put a in, and here we're going to get a negative number. And when you go minus a minus, it's going to make that thing positive. So we're going to get b over 3 times a. When we take a to the third, and 2 of these will cancel. And by the way, this is the total area here. I'm going to go ahead and save that. because we can use it in our integral for y bar. So BA over 3 or AB over 3. Okay, so our x bar, and get this simplified here, is this expression, and it's negative, which we should expect. You know, this is to the left of the origin. All right, let's do the b's. Looks like they are going to cancel. Looks like we're going to get minus 3/4 a for x bar for the blue geometry. All right, let's start working on y bar. I think I'll save a picture of this. Now we're going to get rid of this stuff. All right, so now what we're doing is it's all about this. It's about that right there. We're trying to average that distance. Now I say distance, we want it to be a coordinate. So from here to here is defined by the function value. I'll just put y for now. Then we want to multiply by the area, which is going to be length times width. Then we're going to integrate that from minus a to 0. And then we're going to divide by the total area, which we already know to be AB over 3. We don't need to work that again. All right, so we're going to have integral from minus a to 0. Okay, the y value, including the sign, that's going to be minus bx squared over a squared, okay, times the area, and we want that to be positive. It's what's giving us our weight here, so that's going to be times bx squared over a squared. Oh, whoops, I almost made a little error. I got to go back here. So this y value, it's not from here to here, it's from here to here, which would be half of this. Oops. Go ahead and just put that 2 right there. So again, very important part of this problem. See, when we were doing x bar, from here to here is all of x, if you will. But from here to here is only half of y. So this is what we're averaging. And then this gives it a weight multiplied by area. So I think I've got that minus y over 2. To make this an area, we need to multiply it by dx. So that's length minus y times width dx. Divide out total area, which we already know. Okay, constants, all sorts of good fun here. Let's see, minus b squared over 2a to the 4th. Then we have antiderivative of x to the 4th, which is x to the 5th over 5. From minus a to 0, and again, that's over total area. We'll clean that up in a minute. Oh my goodness. Of course, when we put the top limit in, we get a 0, and then we're going to do minus the bottom limit. Now, when we do minus the bottom limit, this is going to be negative from this. This is negative, and don't forget there's the minus sign. So when it's all said and done, we're going to get a negative number out of that, which is fine. That's what we were expecting. Okay, a, let's see. Let's do this. B squared over 5. And then there's a 2. I'll make that a 10. I'm going to make sure I do this right here. I've only had 1 cup of coffee today, so humor me. Minus b squared over 10, a to the 5th or a to the 4th. All right, times a. And that's all over our total area, which we found to be a times b over 3. All right, minus, let's see what we get here. 3/10 for a numerical value. Looking like these are going to cancel one of these. Looks like minus 3/10 b for y bar. Looking at the geometry here, so it's less than half of b, and you'll notice that there's more area here than here. So that's, you know, I would expect it to be minus less, closer to 0 than minus 5/10 b. So I think I'm pretty confident in that. So again, the point of this video is how to set up and calculate, set up integrals to calculate centroids for area problems. I hope that this has helped out. Remember, when you're working your homework, draw a good picture, draw the element, label the x bar and the y bar for your element, and then you're averaging this. Take this guy, multiply by area, integrate, divide by total area. Take this guy over 2. And this can vary some. If you had another curve, you can have slightly different versions of that. I'll try to make other examples up here that have different looking y-bars there. But anyway, you set up an integral, multiply by area, divide by the total area to find y-bar. So hope that this video helps with how to set these up. Have a great day.